All right, here's the whole setup. This is the ignition system all on the bench. And I'll pan down here just to show that I have it hooked up to a simple car battery through this cable, which is nothing more than a lamp cord. A little switch to turn on the 12 volts here. And let's see, let's work on the components here. So here's the distributor, which we set up in the other video for the angles. And this is the ignition box, which was also in the other video while I was trying to change the transistors. Those transistors have been changed. They're down here. And I did point out that the thyristor was in the wrong spot last time. So last time I said this guy was a thyristor. That's actually a diode. Thyristor is actually back here. The guy with the 2 pins. It's right there. That's the gate that dumps the power through this giant capacitor. I didn't mention that last time either. This big can is a giant capacitor, 500 volts or 700 or something. And that gets, once that thyristor opens, it dumps the current from the thyristor through this ignition coil, through this array of stuff. There's a primary side, which is this guy and ground, and then the other side gets energized and eventually ends up through this high tension wire over to this spark plug. Now usually the spark plug would be connected, or this wire would be connected to a distributor cap on here, which would then put the high voltage through this rotor out into the rest of the engine. So we're skipping that part, and that also lets me rotate this rotor without having any chance of hurting myself, because there's no high voltage over here, it's all on this side. So when I turn this on, it's going to hum, and it hums a lot louder on the video than I think in real life. You don't need earplugs or anything, but it does kind of overwhelm the video. It hums because of the oscillating circuit, which I'll show in another video, and it makes this transformer buzz, and the 250 hertz or whatever it's buzzing at is normal. So I'll turn that on, and we can see it makes sparks, and then also we can see this thyristor trigger that I didn't understand before. I'll show this again real quick. So you have 2 transistors which are connected through this transformer coil. As one base gets turned on, it makes the coil flip polarity because the inductance induced current, and it turns the other transistor on, and it kind of flips back and forth, and that oscillation is what causes high voltage on this side and charges up this giant capacitor, which I just showed. There's this trigger circuit. These are the points. So these are normally closed. When the points open, then it sends a pulse of current down this thing, opening this thyristor. Thyristor then shorts this capacitor to the other side of the coil, this primary side, and that causes the spark to go out. Oh, so I actually was wrong about that. This primary side is connected through the capacitor and the 12 volt side. And then the ground is actually from the spark plug side, secondary side. So, okay, so let's, we'll turn this on, and then we can see it go. So there's that humming sound. And the thing that I wasn't sure about with this diagram is how this point here gets to be more positive than this point, because it has to actually get higher than 12 volts, because it's using the 12 volt side as the common for the high voltage. It does work, so there's a negative bias here, and then when this is grounded, this is a 0 volts, and then when this inrush of current comes in, it somehow creates a pulse that's slightly higher than 12 volts, actually like 14, which opens this gate and lets the current go through, and then it reshuts itself and goes back and forth. Okay, so here we go. So all I need to do now to get this thing to spark is turn this rotor. So I'll turn this by hand. You can hear it clicking. I'll go in here and zoom. And there it goes. So this works good. All right. So there's the system. So now if I look over here, what I've got is the oscilloscope, and it's showing, you can see that it's triggering on this thyristor. So I have the thyristor showing negative 0.5 degrees or volts or so. That's here because it's below the line I have. If I put it on ground, you'll see that this is, oh, maybe not. Oh, the wrong channel. This one. There. So that's 0 volts. That's negative. And then these pulses that the thyristor is pushing out are randomly higher than 12 volts, because this is a 2 volts per division, so it goes above the zero line about 2.5 volts. So that's enough to open the thyristor and make it work. I can hook this up with a power drill and spin it, and then you can see the sparks going, and this thing will actually trigger on that pulse. I'll do that next. Okay, here you go. So I hooked the power drill just up to this rotor, and you can see if I turn it now, every time those pipes close and open, and it's causing the sparks there. This is simulating the car driving. And over here you could see those trigger points. Now if I adjust this correctly, it'll actually trigger on that, and you can look at the pulse a little better. So now it's triggering. It's triggering right on that pulse. If I make the scan time a little faster, I think you can see that's the shape of the pulse. So that's the discharge from the capacitor going to the thyristor and then opening. So proof of concept that the thing works. I'm not exactly sure how the extra 2 volts gets there, but maybe somebody can inform me, or I'll have to ask some of my buddies. Oops. And that's it.